But how do we get to know that this is a reduction reaction? We define the reduction as either addition of hydrogen, removal of oxygen, gain of electrons, and we also defined it as any reaction that involves decrease in oxidation numbers or oxidation states.
Why settle for ordinary lessons? Discover a smarter, easier way to learn. This is Muto Online. Get instant access to notes, past papers, and scenario-solved lessons, all tailored as a competence-based curriculum.
Whether it's UNEB prep or just extra practice, we're here to make learning fun and easy. Subscribe now and let's ace those exams together.
Please, if you are watching this video first, remember we have other videos we recorded. Watch them first so that you can get the concept well, the flow of the concept. Don't forget to download the work. It is already uploaded on our website about this topic. Don't forget to subscribe, to invite others, to share if you really feel like you're gaining. I have gone through the concept of reduction. Did you know that I think we see most of the things, the silver-coated materials, the steel-coated materials, the copper-coated materials, where the metal plate any material, for example, wood with a metal surface or a metallic surface. We are going to find that this reduction reaction is greatly applied there. We are going to find reduction in the cleaning department, like in the fabric, the stain removers. These stain removers use this process of reduction to reduce the colored pigments within the stains that are staining the clothes to less oxygen-containing components that do not look so bright in the cloth. The reduction is also applied in the industries, like in the manufacture of ammonia, where nitrogen is reacted with hydrogen. We are adding hydrogen this time to nitrogen to form ammonia gas. We know it as a great raw material during the manufacture of fertilizers. The reduction reaction is also applied in the industrial extraction of iron, where its ore is reduced to iron. We are going to look at reduction in food preservatives, like the ascorbic acid. The ascorbic acid is used as a food preservative in some drinks like the beers. Why? Because the ascorbic acid, being a reducing agent, it will prevent oxidation, or it will lower availability of oxygen within the drink, not to support life of organisms that would have caused the decomposition of the drink. So we are looking at reduction reactions. In the exhaust pipes of many vehicles that use carbon-based fuels, they produce toxic waste gases such as the nitrogen dioxide, sulfur trioxide. They are toxic. These ones are reduced by the charcoal or the carbon in the exhaust pipes to nitrogen, for example, which is a vital step in the purification of the waste air to prevent air pollution. So the reduction reaction has a variety of application. During the process of photosynthesis still, we are going to find that the carbon is reduced by water by adding a hydrogen atom on it, forming glucose. It was carbon previously, but this time we are adding hydrogen to it, forming glucose. This is a reduction reaction. So it has a variety of applications we cannot finish. In the electrolytic cells and batteries, the reduction is used, we shall find reduction that is specifically at the cathode, where positively charged ions like the hydrogen ions are discharged, carrying charge. So all these are applications of reduction reactions. But how do we get to know that this is a reduction reaction? We define the reduction as either addition of hydrogen, removal of oxygen, gain of electrons, and we also defined it as any reaction that involves decrease in oxidation numbers or oxidation states. So long as a reaction involves one of these four, it is a reduction reaction. We already gave one example where nitrogen, it is a gas, is reacted with ammonia, with hydrogen gas to form ammonia gas. This is a reduction reaction for the reason I gave you, that the nitrogen is reduced as a result of adding hydrogen to it. So it is a reduction reaction because there is addition of what? Hydrogen to the nitrogen. This reaction, it is as well a reduction reaction. We shall find that the oxidation state of nitrogen is reducing from a 0 to a negative. We can look at the discharge at the cathode equations. We can talk of, let's say, if copper, if we want to electroplate anything with copper, we put it at something, we use it as the cathode. For those who cover the electrolysis, the cathode is a load or a battery load that is negatively charged, this one here. So the one who wants to electroplate with a metal, we use it as a cathode, such that as these ions in a solution in the electrolyte are discharged, they are deposited around the cathode. So if you want to electroplate this one, metalplate this one with copper, we shall, let's say this is carbon, we shall put this carbon load at the cathode, and then we use a copper solution as an electrolyte. So this one will gain electrons such that it becomes solid copper. This is a reduction reaction. Why? There is gain of electrons. That is one. It is part of the definitions. Two, we are saying this one has an oxidation state of positive 2. But copper, this time, it is copper in uncombined state. It's not an ion still. So it has an oxidation state of 0. I think positive 2 is bigger than 0. So there is a reduction in the oxidation state. We can talk of other related examples of equations of this kind here. We can talk of the reactions at, we can talk of the formation of ions or ionization of gases. For example, the chlorine. The chlorine will always need to gain electrons such that it becomes a chloride ion. Remember, this is a reduction reaction. Why? It is a reduction reaction because there is gaining of electrons, and 2, we are going to notice a decrease in the oxidation state. This one has an oxidation state of 0 because it's not in its combined state, neither it is an ion, but this one has an oxidation state of -1. So I think a 0 is bigger than a -1. So this one as well, it can be a reduction reaction for those 2 reasons: gaining of electrons and reduction in the oxidation states. Remember, as we said, you must know the category of a redox reaction and the reason as well. We don't cram, we understand the concept. We remember that the work is already uploaded at our Mto Online website. It is already there. Please make for me a simple research and talk about reduction in terms of loss of oxygen, and put it in the comment section, please. Just a request. This is Teacher Alan, representing Mto Online. Please don't miss our next video. We are going to be talking about redox reactions and then oxidizing and reducing agents. That is our next video. We are tuned.
Why settle for ordinary lessons? Discover a smarter, easier way to learn. This is Mto Online. Get instant access to notes, past papers, and scenario-solved lessons, all tailored as a competence-based curriculum.
Whether it's UNEB prep or just extra practice, we're here to make learning fun and easy. Subscribe now and let's ace those exams together.